Hello children, so we are back with questions on probability. We are going to cover in this video type 3 questions of our website examprep.world. Parallelly open the website and open learn and practice zone. There you choose the topic probability. In that type 3 questions you can see practice this type, and then let's begin with that. This video will include questions on probability of compound events. Two events compound, okay, 1 and 2 events together. So let's see what kind of questions are actually possible which can appear in exam. Okay, read the question. A boy and a girl were each asked on which day of the week they were born. Okay, we have to find the probability that the boy was born on a Monday and girl was on a Wednesday. Right now, let's figure out. There are 7 days in a week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. In how many ways boy is on Monday, boy, and girl is on Wednesday? Only one way it is possible, that boy is on Monday and girl. And how many total ways are possible? A boy can be born on any one of these, which is 7 ways, and girl can also be born on any one of these days, which is 7. 7 times 7, 49. So total options here are, total possibilities is 7 times 7, which is 49. And what's the probability that boy is on Monday and girl? This is one option. So the probability of happening, the first one, is just 1 upon 49. Understood, right? Now, the boy was born on weekend. Now look at this. Boy was born on a weekend. So either it can be Saturday or Sunday. Saturday, how many ways? 2 times. So boy can come on Saturday or Sunday. So this is 2 ways it can happen. Girl can be born on balance 5 days. 5 days. So 5 times 2 is 10 different options are possible. 5 times 2 is 10. Now, for this, it should be 10 on 49. That is simplified form. Okay. Both children were born on the same weekday. So it can happen in 7 different ways. Boy and girl on Monday, boy and girl on Tuesday, boy and girl on Wednesday. So 7 possibilities. So for this, the total possibilities is 7 and total is 49. So it is 1 on 7. It can be simplified. That's your answer. Understood? So boy and girl, birth of a boy and birth of a girl is compound event, and we are trying to do the probabilities for both things happening. Happening together. So I'll move away from the board, note this one. I hope you understood the way I have done. First, what we did, we found the total number of possibilities, 49, and then we checked how many possibilities are there for each one and divided by the total. We get the probabilities. Okay. I hope you have written this one. Let's do the next question. A coin was flipped 200 times. This is experimental probability, compound events. 143 times it lands on tail. No, on heads 143 times. Coin is biased. No, it should be heavier on the tail side. That's why head is coming up. It's a biased coin. So anyhow, we have to do our question. So all heads. Coin is tossed 3 times. First time, probability of getting a head is how much? 143. This is not theoretical. If it was theoretical, you would have done half, 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 which is 1 by 8. But here the probability is different. First time you toss it, you are getting 143. Probability of getting a head is 143 on 200. When you toss it second time, once again the probability is same. So we will multiply 143 by 200 times 143 by 200. For all 3 times, if you get head, the probability is quite high. So this is 143 by 200 cube. Okay. So in calculator you can straight away do 143 by 200 whole cube. Let me do it for you. Let's see what answer we get. 0.36, 0.365. Almost little more than 1/3. The chances is little more than 1/3 because you are doing it 3 times. Okay. All tails. If it is all tails, what is the probability of getting one tail? Probability of tail was 143 is already done. So for 57 times the tail was landing, remaining times, okay, on 200. Again, because all tails are 57 on 200 and 57 on 200. So it is 57 on 200 whole cube. Let's figure out what's the answer. 0.023. 2.3% is the chance, very less. So if you want me to convert into percentages, multiply by 100, it is 36.5% of the chance, and here it is just 2.3% chance. So if we had the coin, I would have always bet on heads, because we know the coin most of the times gives heads. Theoretically wrong, but experimentally some coins are biased. It will be heavy on one side, so the heavier part lands in the bottom. Little bit of physics. Anyhow, I hope you have understood the mathematics in this question. So please note it. Done? So let's go ahead and see what next. Colorful question. We have 2 spinners. In this spinner, this spinner is divided into 3 sections. 2 are red and 1/3 is blue. See, 2/3 is red, 1/3 is blue. In this section, blue is 1/4, red is 1/4 and green is half. Right? Now both spinners are spinning. If the first spinner is this, so 2/3 is red. So 2/3 the probability. So what is left for blue? You will have only 1/3. Okay. Now here for probability for red is only 1/4, right? So they have given 1/4. What about blue? That is also 1/4. What about green? It is half. Right? Probability for the second spinner. So they have given half here. So 1/4 and 1/4. Our chart is completed. The tree diagram with the probabilities are done. Not very simple. Find the probability that the spinner lands on the same color. So either it can land on red and red, or blue, green. It doesn't have green. So we have to add probabilities of red and blue because you don't have green here. So you can get red and red. What is the probability of getting red? 2/3 into 1/4. 2/3 times 1/4, which is 2/12. I will simplify later. What is the chance of getting blue? 1/3 blue and blue, which is 1/3 times 1/4, which is 1/12. Now, because if it is landing on same color, 2 ways it can happen. Let me add this. 2/12 plus 1/12, which is 3/12. So first answer will be, the answer for 1 is 2/12 plus 1/12, which is 3/12, which is equal to 1/4. 25% chance is that both the spinners land on the same color. Either they will land on red or blue, because the first spinner obviously doesn't have green color. Now spinners land on different colors. It's very, very simple. 1 minus 1/4. This is same color. So different colors is 1 minus 1/4. The answer to this one is very simple. 1 minus, for same color it is 1/4. The balance is 1 minus 1/4. 3/4 is the answer, that spinners land on different colors. Exactly one of the spinners lands on blue. That means either this comes on blue or this comes on blue. So we have to see that probability. First note this, then note this one, then we'll do the third one. Pause this video here, copy this, Done? Let us do the third question. I will erase this stuff here. Right. One spinner lands on blue. So RB we have to do for R and B, red blue or blue, they said exactly one. So blue and red, then blue and green. So if you find the probabilities, we'll total them. For red and blue, how much it is? Red is 2 by 3 and blue is 1 by 4. So 2 by 3 times 1 by 4, which is 2 by 12. What about blue and green? Blue 1 by 3 and green is 1 by 2. 1 by 3 times 1 by 2. Look, blue 1 by 3 and then green is 1 by 2. How much is this? 1 upon 6. I'll simplify this. This is also 1 upon 6. Blue and green. Go for blue 1 by 3. Oh, I did a mistake here. This one I did 1 by 3 times 1 by 2, which is 1 by 6. Now blue and red, blue and red, 1 by 3 times into 1 by 4. 1 by 3 times 1 by 4. Let's see, 1 by 3 times 1 by 4, which is 1 upon 12. 1 upon 12. Now if I add them, will I get my answer? 1 by 6 plus 1 by 12 plus 1 by 6. So our answer for 3 will be 1 by 6, or we will write it 2 by 12 because LCM is 12, plus 1 upon 12 plus 2 upon 12. I am changing it to common denominator, so our job becomes easy. 2 plus 1, 3, 3 plus 2, 5. 5 upon 12 is your answer for 3. Okay. It was easy to understand. So pause the video. At different stages you can pause and note. Right? Once you do on your own, you will understand it better. Let's do the next question. Once again, colorful things. A ticket. These are all tickets. Okay. So we have 3 colors of tickets: green, blue, and red. Draw a tree diagram to display the possible outcomes. Selected random from each of the box. When you select from here and you select from here. So how many in box A, how many red are there? Red are 3. We will write it in RBG. Blue are 2 and green are also 2. Total are 7 tickets total here. And in this, red are 2, blue are 3 and green is 4, 7, 8, 9. Total is 9 tickets. Now you can do on your own. Zoom and see, count, right, the number of tickets. Now we have the data. A blue ticket and a green ticket. We pick from here. Are this thing dependent? No, they are independent events, because what I pick from here and what I pick from here are 2 different stories, right? So when I pick one ticket from box A, the first one should be blue. So probability of blue here is 2 upon 7. And then probability of green from here. Probability of green is green is 4 upon 9. Then probability of blue and then second box green, multiply them. The first answer will be 2 upon 7 times 4 upon 9. So your first answer becomes 8 upon 63. Okay. Exactly one pink ticket. Exactly one pink ticket. So that means what are things are possible? You get pink here, exactly one pink. So, but you have to draw a tree diagram. Without that, you won't be able to do. Okay. So, first box, when you draw, either you will get red. I have written red, so I will use red. Okay. Pink is nothing but red for us because I used red from the beginning. Red, blue, green. What are the probabilities? Let's write the probabilities here, or let's do the second box. Red, blue, green, red, blue, green, red, blue, green. Let's write the probabilities of each one of them, so calculation becomes easy. Getting red is 3 upon 7, getting a blue is 2 upon 7, and getting a green is 2 upon 7. Here red is 2 upon 9, getting blue is 3 upon 9. I am not simplifying to 1:3 because final calculations help us if it has a common denominator, and green is 4 upon 9, and these things remain same, 2 upon 9, 3 upon 9 and 4 upon 9, 2 upon 9, 3 upon 9 and 4 upon 9. Now tree diagram with the probabilities are done. The question is exactly one pink ticket, pink or red. So for us it is red, so it is red and blue. The first option will be red and blue, then red and green, then blue and red, blue, blue, blue. Here there is nothing now, blue, 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 green, there is no red. Now green and red, green and red. Now green, blue, green, green. So these are the 4 ways. You have only one red ticket or one pink ticket as they are asking for. Now what is the probability of red and a blue? 3 by 7 and 3 by 9. 3 by 7 times 3 by 9. This is 3 by 7 times 4 upon 9. Blue and red. 2 upon 7 times 2 upon 9. Green and a red. 2 upon 7 and 2 upon 9. Now our data is ready, so we can just do the multiplication and total it. So it is 9 upon 63. This is 12 upon 63. This is 4 upon 63. This is once again 4 upon 63. Add them all. So denominator is 63. Numerator is 9 plus 12 is 21. 21 plus 4 is 25. 25 plus 4 is 29. That's your answer. That you get exactly one pink ticket or red ticket. So see, you have only single red here, single red here, single red here, and in any other options you don't have red or either some are different colors. So I will move away from the board. Please note this the way I have done. Now in the last question, find the sum of probabilities in B. So you got probability of this and probability of this, you add them and that will be your answer. Simple. Okay. So let's see. I think we have come to an end. Yes, we have come to an end of these kind of questions. There are few more questions, they are exactly same. So I have given in this video all types how you should be able to solve them. I suggest that you practice well from our website so that you will be through with this topic. Thank you.